All right, class, we're going to go through a couple of things today. First off, we're going to talk about congruency. We're going to do a couple of different constructions today. I'm going to show you two different ways to work on these constructions. One, I'm going to be using a compass. These are actually surprisingly hard to find unless you look on Amazon. I actually found mine at Wegmans. Target has none. So if you're in the market to buy one, they're like, I don't know, $1 or $2. Wegmans has a bunch of them. And then I'm also going to show you how to do some different constructions on a website, which is actually pretty simple to use. So there'll be a second video kind of walking you through how to do that. That's the one that I'll probably be showing you guys when we're doing our live lessons here. So, okay, first question. It says, which segments are congruent in this image of a pencil? So when we're looking at different congruency factors here, especially if I'm given a picture here, that's what these little tick marks are representing. So if you notice, we have a couple of different segments in here, all with just different varying tick marks. So the segments that have the same number of tick marks are represented of being congruent segments, as in of the same length. So what does it mean if two objects are congruent? It means they are the same. They are the same, and that's usually talking about, when you're talking about segments, talking about the length of the segments. We'll get later on into angles and congruent angles. That means their measures of their degrees are the same, but in this case, since we're talking about segments, they are the same length. So in this example, we see that segment AB and segment AG, it's a G, both have that one tick mark, therefore they are both the exact same length. So the way that we can write that, using our proper notation, AB, it's a line segment, so I get the little notch above the AB. And then the congruent looks like an equal sign, but then it has this little like tilde above it. That just means the congruent symbol. So segment AB is congruent to segment AG. All right, next one, we can also see that segment BC is congruent to segment GF because they both have 3 tick marks. So I'm just gonna write that down. We have BC, that's a segment, and that is congruent to segment GF. All right, last one we have here, we have a segment CD and we have a segment FE. They both have 2 tick marks, therefore I know that they are congruent to each other. So I think you guys get the picture here. Segment CD is congruent, remember equal sign with the little like tilde above it, and that is congruent to segment FE. There we go. All right, next one. It says, what happens if I asked you to draw a segment that was the same length of BC, but I did not give you a ruler, so you wouldn't be able to measure it? That's where our construction comes in with a compass. So it looks like I do have enough space where I can kind of squeeze this in on my paper. When I get down to the bottom of the page and I'm doing another different construction, I'm gonna have to do it on a separate sheet of paper. So first thing I wanna do is I'm just gonna label this AB so I can reference it. So this is segment AB. First thing I want to do is I want to take my compass and I'm going to put the sharp point of my compass just on point A. And then, oh wow, look at that, it's almost perfect there. So then I want to make sure my pencil kind of arcs point B there. So it looks like I'm a little bit further away, but that's fine. I want the full length of it. So now what I can do is I'm just going to make a new segment. Let's call it CD. I can make my own point C. And then what I'm going to do is I'm going to take the point of my compass, I'm going to place it right on C. And if I do that same arcing motion like this, it doesn't matter where I put my point on this arc. All of these spaces are equidistant from this point C. So I'm just going to put it somewhere in the middle. Let's call this point D. And unfortunately, I don't even have a ruler, so I'm going to use my calculator case as my ruler, hopefully. All right, let's see if I can do this. All right, so CD, just little straight edge. You can use like a notebook or something. Not the greatest line, I apologize, but you guys get the gist there. All right, so if I wanted to make a segment congruent to this one right here, I'm gonna do the exact same thing. I wanna put the pointy end of my compass on the first point, and then I'm going to move my pencil in till it's about the edge, make a little arcing motion. All right, let's call this point, I don't know, X, Y, doesn't really matter. All right, I'm gonna make a new point down here. Let's make it M. And then if I'm constructing a segment, I'm just gonna put the point of my compass here, make a nice little arc. Doesn't matter how high you go or how far you go. I'm gonna put my point anywhere on this arc. Let's call it N. And then once again, I'm just going to connect those points using my not so good ruler. Ooh, when in doubt, just make the point a little bit bigger. Okay, there we go, all done. So now I know that CD is congruent to AB, so if I want to be super fancy, I can make a little tick mark here showing their congruency. And I know that XY is congruent to MN. I'm just gonna put 2 tick marks so I don't get them confused and mixed up with each other. All right, so constructing congruent segments, super easy. It's pretty much just one compass move. It's even easier on the computer when I show you guys with the app. All right, I don't have a partner, so I'm not gonna exchange it. Okay, so now it says, observe the following segment. Each indicate where you think the midpoint lies by drawing a point and labeling it M. So midpoint, pretty self-explanatory. It is a point in the middle of the segment. That's why I call it midpoint. So let's just give it a go here. Let's call this M. And let's go right here and call that M. So this is my midpoint accurate? Really have no way to tell. I mean, to me it looks accurate, but unfortunately, I can't mathematically say that it is accurate because I just randomly picked a spot. Maybe if I would have went over a little bit further, it would be more accurate, but I'm not really sure. So this is how can we make sure our midpoint is more accurate? We can do a construction. We're going to use our compass to construct a midpoint of a segment. And it says by finding the midpoint, we are actually constructing the segment bisector. Segment bisector, and for this specific case, our segment bisector is actually going to be a perpendicular bisector as well. So when it crosses over my segment, it's going to cross at a 90-degree angle. Okay, so I need a little bit of space here, so I am just going to get a blank sheet of paper, and I'm going to label A, and let's label this B over here. I'm going to connect these. I'm just making a segment here. All right, I didn't have enough space on that paper, so I'm just going to make a segment here. All right, that's not too bad. All right, so when I'm constructing this perpendicular bisector, right, I'm trying to create a midpoint here. What I want to do is just like when I was making a congruent segment, I'm going to put the sharp point of my compass on my first point here. And I want to make sure my compass goes, or my pencil of my compass goes a little bit further than halfway. So if you look here, my halfway is roughly right here. I want my pencil to be a little bit further out. All right, when I do this, I want to make a giant sweeping curve. All right, so I'm just going to kind of move my pencil there. Sorry, I have a bunch of different pens on my desk that are moving around. All right, so I just made this giant sweeping curve here. All right, I'm going to do the exact same thing, but instead of putting my point on A, I'm going to put my point on B. On the computer, this is much easier. I'm not super great with my right hand, but we'll do the best here. So I'm just doing the exact same thing, making a curve. I try to press nice and light. Sometimes if you press too hard, depending on how cheap your compass is, the pencil might extend. So just be careful there. Okay, so now what I have is I have 2 intersecting points both above and below the segment that I just created. If I draw a perpendicular line directly through my segment AB, it is going to intersect my segment exactly at the midpoint, right? Once I draw this vertical line and this perpendicular line, I just create a perpendicular bisector, and it's going to bisect my segment AB at exactly the midpoint. All right, so I'm just gonna make a little point here, make a little point here. I promise next time I'll have a ruler. I didn't realize it was gonna be this bad with the calculator case. And then I'm just gonna draw a line right down there. And where it intersected my segment AB is my midpoint. We'll just call that M. All right, so once again, what I did, just real quickly, I'll be able to show you guys this in class on the actual app. I put my point on my first, or put the point on my compass on my first point and made it a little bit longer than halfway, made a big giant arch. Did the exact same thing for point B. It went a little bit further than halfway, made a big giant arch. Where those 2 arches intersected, I drew a perpendicular bisector, and then where that perpendicular bisector intersected my segment AB, that is known as my midpoint. All right, so not too crazy. Simple little construction there for us. Okay, moving on to the second page of notes. We're going to get into a couple of formulas here in a couple of seconds, in which we'll be using a ton of super important formulas. So it says, find the length of the following segments using the coordinate plane. So I'm not going to use any formulas. I'm just going to simply look at my graph here. First one is segment AB. I'm looking for the length of this red line AB. This one's pretty simple. I can literally just count the number of units that it goes. So it looks like it's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so segment AB is 7, and then it doesn't give you my units, so I'm just going to put units. Sometimes that could be like miles or feet or inches. It's a good habit to just get into putting units there. That way, if it ever does have something, you don't forget it. All right, CD is a little bit more challenging because I can't like say like this is 1 and 2 and 3 because it's kind of diagonal here. So I can use something called the Pythagorean theorem, right? I'm going to make a right triangle out of this, all right? Because I know how high this is going to go. Keep going. One more. It looks like it went 1, 2, 3, 4, 5, 6, 7. Looks like that went 8 units tall. And if I come over here, it looks like it went 1, 2, 3, 4, 5, 6 units long. So I know the lengths of my two legs. Right, if we're using the Pythagorean theorem there, it's a squared plus b squared equals c squared. I'm looking for that hypotenuse. I'm looking for that distance between c and d, my longest side. All right, I know that a is, let's just say 6. I know that b is 8. And I'm looking for c. We'll call this c, right, side c. All right, we know that 6 squared is 36. We know that 8 squared is 64. 36 plus 64 is 100. When I take the square root of 100, we get 10. Technically, it's plus or minus 10, but I know that distance cannot be negative. So I know the length between C, D is 10 units long. All right, so Pythagorean theorem, super useful. You can definitely use it when you're finding the midpoint. The distance between 2 points. However, when my numbers start to get really large, it kind of gets a little sloppy. Like if my point, instead of it being, whatever this is right here, was like, 15, 17. I don't want to have to make a graph and count over 15 and count up 17 spots. It's just a lot of work. So there's a formula that will actually get us those values much, much, much quicker. All right, so that formula is distance equals the square root. We have x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That whole thing is under a radical sign. Basically, it's the exact same thing that we did up here. It's finding the length, right, my run, and that's finding my rise. Exact same thing that we did with the Pythagorean theorem. All right, so we're going to demonstrate this by determining the distance between these couple of points right here. A good habit, point W is my first point, so I'm just going to label it x1, y1. Point X is my second point, x2, y2. I know that's super silly and you guys are all really smart, but sometimes I accidentally mess up and place it in the wrong spot. If I haven't labeled, I know I'm not going to make that silly mistake. All right, so distance equals the square root, and I have x2, which is a -1. -1 minus x1, which is 4 squared, plus my y2 value is a -9 minus 7 squared. All right, we just do this kind of like piece by piece here. And sorry, it's a little small there, but I'm going to do my parentheses first. So I have a -1 minus 4, which is a -5 squared, plus, and I have a -9 minus 7, which is a -16 squared. Love testing you guys on your negatives this early in the school year. All right, we know that any number when you square it is always going to be positive. So when I take -5 squared, I get 25. And when I take -16 and I square it, I get a positive 256. All right, when I combine these two values together, I get the square root of 281. All right, not many people say, oh, today I walked the square root of 281 feet, right? Nobody really knows what that is, so we can quickly use our calculator. Hopefully mine has some battery here. Probably should have checked that out. And it does. All right, so when I take the square root of 281, I get 16.76. I'm just going to round to the nearest hundredth, so we're going to approximate here. So I get 16.76, and that is units. That's how long those spaces are. Sorry if you can hear my cat. He's very talkative. Okay, last thing we're going to do today is we're going to talk about the midpoint. So instead of constructing the midpoint, we're going to actually be calculating the midpoint. We're going to use it to calculate the midpoint of these three values. I'm actually going to skip ahead. I'm just going to do the midpoint of these values right here. So it says it says plot the following coordinates on the coordinate plane to the right, then find the distance between the endpoints and the midpoint. So I'm going to skip ahead and I'm just going to find the midpoint just to kind of make this video not so long. So the formula for that is going to be x sub 1 plus x sub 2 over top of 2. Right, I'm finding the midpoint, so the middle, which is technically the average of the two. And then I have y sub 1 plus y sub 2 over 2. So relatively easy calculation. The reason why I have it written like this, it's written like a coordinate point. Remember, a coordinate point is always an x and a y value. So it's written like that in parentheses with a comma in between. All right, so once again, I know this is silly, but A is my first point, x1, y1. B is my second point, x2, y2. And for this video, guys, I'm just going to calculate the midpoint instead of having you guys sit through another grueling distance formula example. Okay, so x2 value is a 3. 3 plus my x1 value, which is a negative 5. That's over 2. And then my y2 or my y1 value, it really doesn't matter. You can inverse these. I'll do y2 first since I did x2 first. I have negative 5 plus 9 over 2. All right, sorry I wrote my 2's differently. That was kind of weird. All right, so 3 plus a negative 5 is a negative 2 over 2. Negative 5 plus 9 is a positive 4 over 2. And I can keep simplifying. This right here gives me a negative 1. 4 over 2 gives me a 2. So the midpoint is a negative 1, 2. If I wanted to show this just graphically, I can quickly go ahead and plot these points. I have a negative 5 and a 9. So 1, 2, 3, 4, 5, and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is point A. And then point B is 3, negative 5. So 1, 2, 3, 1, 2, 3, 4, 5. Let's use my nice ruler again. Didn't realize I was going to be using a ruler 17 times. All right, and connect these guys. And then hopefully, if I did this math correctly, negative 1, 2 is on my line, and that looks to be relatively, at least mathematically speaking, directly in the middle of my line. That is my actual midpoint. All right, you guys hopefully could pause this video, try finding the distance between these 2 points using that distance formula. We have one last algebraic example to go through, and then we are done for this video. All right, last example, and then I'll show you guys what I'll post the homework separately to this so you guys will know what to do. It's going to be some of these questions on this page. So it says, what if the segments weren't on coordinate planes and you're still asked to calculate the distance? In these cases, we are going to set up an equation and use some algebra. So it says, find the measure of PQ. So I'm looking for this distance. And I know that Q is the midpoint of this entire segment PR. So since I know that this is the midpoint, I know that these two little segments are congruent because this cuts this entire segment in two. So if you want to, you can just go ahead and draw a little tally mark in there showing that those are congruent. Since I know that these two things are equal, these two segments, PQ and QR, are congruent, I can set them equal to each other. So x squared minus 2 equals 2x squared minus 18. And then now all I really have to do is I want to solve for x. So I'm going to get everything on the same side, solve for x, and then try to find out the distance of PQ. Find the measure of PQ. All right, so I'm going to subtract x squared from both sides. Bring this down. This gives me an x squared minus 18. I am going to add 18, trying to get my x's all by themselves. Cancel that out. Negative 2 plus 18 is 16. All right, so now algebraically, when I'm getting rid of a squared, I can take the square root. That's how you cancel that out. We know the square root of 16 is plus or minus 4, but in geometry, when we're talking about distances, it's only the positive distance. You can't walk negative 4 feet. And then lastly, 4 is not my answer because I need to figure out what is this distance right here. So I'm going to take 4, plug it into my x, because that's what x equals, and then solve to figure out what the distance of PQ is. All right, so we're taking x squared minus 2, and I'm going to plug in a 4. 4 squared is 16. 16 minus 2 is 14. It doesn't give me units, so I'm just going to write the word units. PQ is 14 units long. All right, guys, thanks for listening in. The homework will be posted. I'll also post a second video, just a real quick video, showing you how to use that website if you wanted to do some of your constructions that are just a practice. Have a great day, guys.